In this video, you are going to learn what a matrix is. First, let's make a new heading. We'll call this one Matrices. 1, 2, 3, 4. A matrix is like a vector because all the data in it needs to be of the same mode. So just like you learned when we went over vectors, vectors can be character, numeric, integer, or logical, for example, among some others. So when you're in a matrix, you also need to have all your data of the same mode. For example, all numbers, all numeric. But you can think of a vector as being one long column in, say, a spreadsheet if you're in Microsoft Excel. A matrix is different because you can add columns. So we say that a vector is one-dimensional. It has one dimension, just one column. But whenever you're with a matrix, you can have more than one dimension. You can have two dimensions. And in that way, you can have many columns in your data. Let's start by looking at the documentation for matrix. And I run that code. Here in the R documentation, you can see that matrix has a couple different functions that you can use to see whether or not it's a matrix. And here under usage, this is the most important bit from this documentation. And let's just go ahead and use it exactly. So type along with me, matrix. First, we give it our data. For now, we'll just use a range of numbers. Let's do 1 to 30. Then we give it the number of rows that we want. In row equals 3. Then we give it the number of columns that we want. In column equals 10. And then we have by row, and we'll say false for this one. And I'll explain what these different arguments mean after we look at the output. I run this code, and you can see that the output is a matrix with 1, 2, 3 rows. Number of rows is 3. And 10 columns. Number of columns is 10. And here's our data. Our data is the numbers 1 through 30. Now, let's look at what happens whenever we say by row equals true. So I'll go ahead and copy this code, put it here, and call this true. Now I run that code. Can you notice the difference? When I had by row equals false, the numbers went up according to the column. So we went down the columns to go through our data. But when I have by row equals true, now the numbers are going up along the rows. Let's save this second example. I'll copy it again. Let's save it to variable. We'll call it matrix test. And we'll assign matrix test to the exact same matrix that we just played around with here. Now we have matrix test, and this represents the same matrix here. Since we now have matrix test as our variable, we can do things with matrix test to learn about our matrix. For example, we can use indices to get information about our matrix. A matrix is ordered. So if you look down at the examples, you can see here, for example, that you can use this kind of syntax, you can use this kind of code to look at parts of the matrix. Because the matrix is ordered, we can pull out information in an ordered way. So we'll do matrix test, and then we'll open brackets, and we'll do, say, 1 comma 0. And now, look, the output is integer 0. What if I did matrix comma underscore test, and then I looked at 1 comma 5, and I run this code? Now it gives me 5. So I go into my matrix here and look at where 5 is. So for the first one, 1 comma 0, I get integer 0 back. That's because there's no data in the place 1 comma 0. 1 is our row and 0 would represent our column, but we don't have a column called 0, so we get integer 0 back. Here though, I want the number that is at row 1, column 5. So we come over 5, and here we have 5. You can play around a little bit and pull out different numbers at different indices, like maybe 3 comma 10. And we get 30 back because we're at row 3, column 10. This is helpful whenever you're working with a very large piece of data and you need to do things with it. You'll use indices a lot. There are some other functions that we can use as well that come along with matrix and other types of data structures like this. We can use dim, which is dimension, and we can put in our matrix. And I run that code, and you can see that it's 3 rows and 10 columns. Those are our dimensions. We can use in row. Three. In column, which is number of column. 10. We can use head. And because we're working with a smaller matrix, I'm getting everything back. But if we were working with a much bigger matrix, head would just give you the first part, and we can see specifically how much it would give you by looking at the documentation. It returns the first or last part of an object. And you can give head a single integer that tells it how many rows or columns you want to see. Similarly, with tail, and again, we're seeing the whole matrix now because it's a small matrix, but if this were a bigger one, we would just see the end of it, the last part of this matrix.